Hello everyone. In this video to see architecture level approach for low power design. In previous video to see the VT-CMOS and MT-CMOS circuit for the designing of low power and low voltage low VT applications. So these two techniques it is only efficient for designing low power and low voltage logic circuit. It may not be used for universal solution to low power CMOS logic design. So this certain applications where variable threshold voltages and multiple threshold voltages VT-CMOS and MT-CMOS are infeasible due to the technological limitations. So for that we go for the system level architectural, that means architectural level approach for low power design. So the in this architecture level approach low power design method having two approaches. One is a pipelining, another one is a parallel processing approach, that is also called as hardware replication. So in this video you have to see the approach for pipelining for getting the low power design in an architecture level approach. So here this is a pipelining approach. In this approach, we have to explain with a single stage as well as the n number of stages. In a single stage, the logic circuit is connected with two register, input register as well as the output register. So the input is given to the first input register. That will be stored in that input register. Then the output of register is connected to the corresponding logic function. The logic function is performing the corresponding logic. Then the output is stored in that register. Then we have to take the corresponding output. So here in that single stage we have to give the clock. The clock is given to the F clock is given to the corresponding register. So here the F input is given to register, then we have to take output. So here in this circuit the supply voltage VDD is also given to the corresponding logic function. So the propagation delay for a single stage is based on the corresponding characteristic, that is this output characteristics. So here when you are giving the input based on the clock, so but the output is taken after getting the completion of the first clock. So the latency of the corresponding single stage pipelining approach is, that is, 1 clock signal. So the total clock time period is equal to 1 divided by F clock. So this is a simplified timing diagram for analyzing of the corresponding single stage pipelining approach. So next we go for the pipelining approach for n number of stages. So here now we have to calculate the power of the corresponding single stage. Here the single stage power is equal to C total into VDD squared into F clock. So that means is equal to the corresponding dynamic power dissipation for the corresponding circuit. So here the total C total means that is calculated for the capacitance of input register and capacitance of output register as well as the capacitance of the corresponding logic function. So the C total is calculated based on the capacitance of input, output register and the logic function, and the supply voltage is given to the logic function, so that is called as VDD square, and we have to give the clock to the corresponding register, that is called as the F clock. Okay. So next to see the pipelining approach for n stages. So here the n number of, in this pipelining approach we are connecting n number of logic function in a cascading with the n minus 1 register of arrays, because in that pipelining in a multiple stage, the input of register is connected to the corresponding logic function, the output of logic function is connected to the next register, then the next register output is connected to the next logic function, then the output of logic function is again connected to the corresponding register. In a similar way, the n number of logic function is connected to the corresponding register. So we have to utilize we are going to utilize the n minus 1 register for finding the pipelining approach for the n stages. So here the F clock clock is also given to the all the register. So the propagation delay for the pipelining stage is calculated, that is equal to the propagation delay, that is maximum propagation delay from input to output divided by n. So that is denoted as T clock. So the total clock time period is equal to the maximum propagation delay for the input to output. So this is the timing analysis, timing diagram for the pipelining approach for n stages. So here when you are giving the clock signal and we have to give the input 1 to first stage, then input 2 to the next one, finally we have to give the input n to the next one, so last one. So when here the output 1, that is the output for the input 1 is it will be getting after completion of n clock cycle. So the latency of this pipelining stages or pipelining approach for n stages is n clock cycle. So that is a disadvantage for this circuit. But where the latency is not important, so at that place we have to utilize the pipelining approach. So for the reduction of low power as well as the power dissipation as well as the area. So in this for n stages, again we have to calculate the power dissipation. So the dynamic power consumption for the n stage pipeline structure with low supply voltages. So we are using more number of logic circuit is used. So we consider the VDD is considered as a VDD new. Then the capacitor is calculated, that is the total capacitor for input as well as output, then the corresponding logic function, and we are using the n-1 register, that is the corresponding capacitor is called as plus n-1 C register into the supply is new supply voltage. Consider the new supply voltages, so that is VDD new squared, and the clock F clock is given to all registers, so I consider F clock. So here C register is a capacitance switched by each pipeline register. Okay, so here, so the ratio between, that is power reduction factor, is achieved by the n stage pipeline structure. That means the P pipeline divided by P reference. So already we know that the P reference is C total into VDD squared into F clock. The pipeline is C total plus n-1 G register VDD new squared into F clock. So for the simplification, these two is get cancelled, and these two, by considering these two, it will be represented as 1 plus n-1 C register divided by C total into VDD new square divided by VDD. So that is the simplified expression for the power reduction factor is achieved by the n stage pipeline structure. So here, so compared to the here when you are consider this architectural approach, here having the area is, it will be small, relatively small area is achieved, and the now single stage is converted into the n number of stages by using the n-1 register array. So here the latency of the corresponding circuit is, it is n number of clock cycles. So this is the acceptable latency. Where the latency is not important, at that place we are using the pipelining approach. So thank you.